In this tutorial, we are going to be focusing on a basic problem that has to do with analytical method development for trace levels of atmospheric gases. Let's assume we are given this kind of problem which says a group of analytical chemists develop an analytical method for determining trace levels of atmospheric gases. An analysis of a sample containing 40 parts per thousand of 2-chloroethyl sulfate yielded the following result. And these are the results. In this case, you have to use this result to determine whether there is a significant differences between the experimental mean and the expected value at the 95% confidence level. How can we solve this problem? In this case, to determine whether there is a significant differences between the experimental mean and the expected value of 95% confidence level, we can perform the t-test. But before then, I simply want to show you some basic formula which I am sure is going to be very useful through the end of this video. The first formula is for calculating the t-value. In this case, formula for calculating the t-value is simply going to be t is being denoted by t, which is going to be mean minus the expected value. If you minus the expected value, you are going to divide everything by the standard deviation, but at this point, remember, into square root of n. In this case, the expected value is this which we are given to be containing 40. Expected value here is 40. What if you ask to find the mean? For you to find the mean, it's simply going to be the summation of all n divided by total number. So, what are we left with? Let's get rid of these places. For us to calculate the standard deviation which is SD, is simply going to be the square root of xi minus mean divided by n minus 1. So feel free to write this formula down as we are going to require it in the middle of this video. In this case, let's start with the first one. To calculate the t-test for each of the experiment, notice that here we are given 3 tables. We can name them A, B, and C. In this case, let's start with the first one. Table A, our data is 40. The data we are given is 43.3, and we are given 37.8, and in this case we are given 42.1. So these are the experimental results. So first thing we need to do at this point is to calculate the mean of A. In this case, we said mean is summation of everything divided by that total number, which is going to be the summation of 43.3. We are going to add that by 37.8 plus 42.1. How many are there in number? There are 3. We are simply going to divide that by 3. In this case, the mean of A, if you plus everything, is going to be, if you plus everything and divide by 43, our answer, and divide by 3, our answer is simply going to be 41.07. This is the mean of A. Well, let's write it down here. We need to know the mean of A, and we need to know the standard deviation of A. In this case, the mean of A is going to be 41.07. So the only thing we are left with is to find the standard deviation. For us to find the standard deviation, which is going to be standard deviation of A, is going to be the square root of xi minus x bar divided by n minus 1. In this case, we are going to have the square root of 4.97 plus 10.69 plus 1.0609. The value of our n is 3, which is the total number. 3 minus 1 is simply going to be 2. In this case, next thing you need to do, that is, we're still on standard deviation. Standard deviation is simply going to be the square root of 16 divided by 2. If you divide everything at this point, your final answer is going to be 2.82. Therefore, the standard deviation of A is simply going to be 2.82. So, at this point, now that we have found the now that we have found the standard deviation, what we need to do next is to calculate the t-value. The t-value is simply going to be the mean minus the expected value divided by standard deviation divided by square root of n. In this case, what is our mean? Our mean is 41.07. 41.07 minus expected value, and we said our expected value is simply going to be 40, divided by the standard deviation. And at this point, remember, we said standard deviation is simply going to be 2.08 divided by n, which is the total number, which is simply going to be 3. If you minus 41.07, if you minus 40 from 41.07, the only thing we are going to be left with is 1.07 divided by, still going to repeat that, which is 2.08 divided by the square root of 3. At this point, 2.08 divided by the square root of 3 is simply going to be 1.07 divided by 0.7353. If you divide these two values, your t-test, which is the final answer, is simply going to be 1.455. And in the case of A, we find our mean, we find our standard deviation, and the t-test at this point is simply going to be 1.45. Okay, let's try the next one. Now that we have already found for the first one, remaining for the B, at this point, the experimental value for B, that is this, let's say this is A, this is B, and this is C. The experimental value for B is simply going to be 34.8, 34.4, and 33.6. At this point, next thing you need to do is to calculate the mean. For you to calculate the mean, that is mean for B, is simply going to be 34.8. You are going to plus that by 34.4. You are going to plus that by 33.6 divided by the total number, and we said the total number is simply going to be 3. If you plus everything at the numerator, your answer is going to be 102.8 divided by 3. For you to find the mean of B, is simply going to be 34.6. This is the mean of B. If this is the mean, let's say this is the mean of B, which we said our answer is 34.6. What about the standard deviation? The standard deviation of this problem, I'm going to show you, it's not going to be hard. Standard deviation of B value is simply going to be the square root of 34.8 minus 34.6 to the power of 2 plus 34.4 minus 34.6 to the power of 2 plus 33.6 are going to minus 34.6 to the power of 2. We are going to divide everything by 2. if you plug in your values, the standard deviation of B, everything here is simply going to be, if you minus 34.8 minus 34.6 to the power of 2, is simply going to be 0.04. 0.04, I'm going to plus that by 0.04 plus 1. If you divide everything by 2, at the end of the day, you're going to be left with 1.08. If you divide that by 2, your standard deviation in the case of B is simply going to be 0.58. In this case, your mean of B is 34.6. The standard deviation of B is going to be 0.58. So what about the t value? The t value for B is simply going to be, we are going to minus mean minus the expected value. We are going to divide that by standard deviation divided by the square root of n. In this case, here is simply going to be 34.6 minus 40. We are going to divide that by our standard deviation, and we say standard deviation here is 0.58 divided by our mean, which is 3, our n, which is 3. If you put everything together, your standard deviation, so your t value at the end of the day is simply going to be negative 16.77. So the only thing we are left with is the last one, which is for C. First of all, we need to find the mean for C. In this case, mean for C is simply going to be the 31.9. You are going to plus that by 31.9 plus 35.3. You are going to divide that by the total number, which is n. If you plus everything at the numerator, your answer is simply going to be 99.1 divided by 3. If you divide everything, the mean of C is simply going to be 33.03. So the standard deviation, the same techniques or the same procedure which we did, is just to insert your value, which is xi minus x bar to the power of 3 divided by n minus 1. And the standard deviation for C, if you do it properly, your final answer is going to be 1.67. What about your t value? Your t value at this point is going to be 33.03. You are going to minus that by 40.0. Divide that by 1.67 divided by square root of 3, and your final answer is going to be 12.73. So at this point, now we have come to conclusion. We can say the critical value at 95% confidence for this problem, which we calculate, which we said is approximately going to be 4.30. Coming to the t value. The t value, right? We have the t value of A, and we are given the t value of A to be equals to 1.55. The t value of B, we are given to be negative 16.77. And the t value of C, we are given to be negative 12.73. In this case, notice that since we said the critical value at 95% confidence level with 2 degrees of freedom is approximately 4.30. In this case, the t value of A is less than 4.30. T value of B is less than 4.30. T value of C is less than 4.30. Therefore, all the set A, B, and C, we can finally conclude and say there is no significant differences between the experimental mean and the expected value at the 95% confidence. Thank you for watching. This is it for this problem. See you next time.